Okay, so we are going if statement like most languages. C++ provides an if statement and supports conditional execution. You can use an if to write a program to count consecutive items, each distinct value appears. Okay, so each how many times the same value occurs. Right. Okay, so we say current value and current value is the number of counting new value. So read first number and show that we say well, read the first value, then we read well. Okay, ensure that we have data to process. Okay, and this is valid. Then we go when they consecutive. If they are same, we increase the count. If they are not same, we add the current value count and then we reset the values. Okay, so simple. And at the end, we print the last file. Okay. Control Z as this will simply value ends. We print the last value. Yeah, okay. Straight simple. And curve equals 0 equals 0 that if curve we take it from either and we say and count equals 1 and we make sure that valid data being entered and we if value equals to current value, if value equals current value, then we increment the count. If it is different, then we simply print out current value occurs count times v update the current value and count to 1. Oh, great, that's all. So while loop and okay. Then in here we print the count of the last element. Very small same idea. Occurs time and we have let's simply C++, C++, okay, we take 5, 6, yeah, 5 appears 4 times. 6, 6, 6, 6, 7, 7. Okay. 67 appears 1 time. Yeah. And 67. Great. Now put B. Much of the code in this program should be familiar from earlier programs. We start by defining val, current val. We'll keep track of which number we are counting. Val will hold each number as we read it from the input. What's new are the two statements. First if, ensure that the input is not empty like a val. And if evaluates condition. Yeah. So if evaluates condition. The condition in the first if read the value into current val. If the read succeeds, then the condition is true, and we execute the block that starts with the open curly braces. Following condition is block, and the block ends with a close curly just before the return statement. Once we know there are numbers to count, we define count. Show count how often each distinct number occurs. Use a while loop similar to the one in the previous section to repeatedly read numbers from the standard input. The body of the while is a block that contains a second if statement. Value equals current value. Okay. The condition in this if uses the equality operator to test whether so if we execute the condition if uses the equality operator to test whether the value is equal to equality operator. Test whether the so if we use yeah. If the condition is false, that is if the value is not equal to the statement. The statement the block consisting of an output statement and defining. Output statement prints the count for the value which is finished processing. Assignments reset count to 1 and current value to val, which is the number registered. C++ uses equal for assignment. Both operators can appear inside a condition. It is a common mistake to write equal to. What happens when the program presented in this section, the input value are what happens in the program presented in this section, the input values are all equal. What if there are no duplicates? Compiling the program as the program you wrote for the exercise and when that can rearrange the numbers so that it handles the input in which the first number is smaller than the second. Okay. Key concept indentation formatting C programs. C++ programs are largely free format, meaning that where we put curly braces indentation comments in new lines usually is not applied to Node programs. For example, the curly brace that denotes the beginning of the body of main could be on the same line as the main position as we have done at the beginning of the next line. Placed anywhere else. Like the only requirement is that in curly braces must be the first non-blank, non-comment character following the main parameter list. Although we are largely free to format programs as we wish, the choice we make is clearly pretty well. For example, a wooden name on a single long line is term. Definition of the legal would be outdated. And estimate the potential right way to format CSC programs. Our belief is that there is no single right term, but that there is value in consistency. Most programmers invent subsidiary parts of the program as done with a statement inside me and the body program. We tend to put the curly braces that delimit functions on their own. We also indent compound IO expressions so that the operators line tend to put the curly braces that delimit functions. So intent, compound, IO expression, operator, lineup. Other indentation mentioned in clear. The most important thing to keep in mind is that the ways to run programs are possible. When you choose a formatting style, think about how it affects readability and comprehension. Once you've chosen a style, use it consistently. Introducing classes. The only remaining feature we need to understand before solving a bookstore problem is how to define a data structure to represent our transaction data. In C++, we define our own data structures by defining class. The class defines a type along with collection of operations that are related to type. The class mechanism is one of the most important features in C++. In fact, a primary focus of the design of C++ is to make it possible to define class types that behave as naturally as the built-in types. In this section, we'll describe a simple class that we can use in our writing. We'll implement this class in later chapters as we learn more about types, expressions, statements, and functions. To use a class, we need to know three things. What is its name? Where is it defined? What operations does it support? For a bookstore problem, we'll assume that the class is named sales item and it is already defined in a header named salesitem.h. As we have seen, to use a library facility, we must include the associated header. Similarly, we use headers to access classes defined for our own application. Conventionally, header files names are derived from the name of the class defined in the header. Header files that we write usually Conventionally, header files names are derived from the name of the class defined in the header. Header files that we write usually have a suffix to attach, but some programs the standard library header typically has no suffix at all. Compilers don't usually care about the form of header files, but ID sometimes do. The sales item class. The purpose of the sales item class is to represent the total revenue, number of copies sold, average sale price for a book. All this data was stored or computed. It's not our concern. To use the class, we need not care about how it is implemented. Instead, what we need to know is what operations objects of that type can perform. So we classify the type. The type name, no, the type name is the same as the name of the class. It's a single item class. So As the built-in types, we can define a variable of class type when we write. We're saying the item is an object of. We often contract the phrase an object of sales item to sales item object or even a sales item. In addition to being able to define variables of types, in addition to being able to define variables of type sales item, we can call a function named icePane to fetch the icePane. We sales item object. Use input output operator read and write objects of the types sale. Use assignment. Use the assignment. Mm. Use the input and output operator to read and write objects of sales item. Use the operator to assign one to another. Use the addition operator to add two sales items object. The two objects must refer to the same icePane. The result is a new sales item object whose icePane is that of its parent, and whose number sold and revenue are the sum of the corresponding values of its operands. Use the compound assignment operator to add one sales item object into classes define behavior. The important thing to keep in mind when you read these programs is that order of the sales item class defines all actions that can be performed by objects of this class. That is, the sales item class defines what happens when sales item object is created and what happens when the assignment, addition, or the input and output operator applied to the sales items. In general, the class order determines all the operations that can be used on objects of the class type. So now, reading and writing sales items. Now that we know what operations we can use with the sales item object, we can write programs that use the class. For example, the following program reads data from the standard input in the sales item object and writes that sales item back into the standard output. Input says that we sold 4 copies of the book at $24.99 each, and the output indicates that the total sold is for total revenue and the average price per book. This program starts with the hash include directive, one of which uses a new form. Headers from the standard library are enclosed in angle brackets. Those that are not part of the library are enclosed in double quotes. Inside main we define an object named book that will use to hold the data that we read from the standard input. The next statement reads into that object, and the third statement prints it to the standard output, followed by printing and adding sales items. More interesting example adds two sales item object. Okay. This program starts by including the sales item object and I stream headers. Next we define two sales item object to hold the transaction We read data into these objects from the standard input. The output expression does the addition and prints the result. It's worth noting how similar this program looks to the one on page 6. We read two inputs and write the sum. What makes the similarity noteworthy is instead of reading and printing the sum of two integers, we're reading and printing the sum of two serial item objects. Moreover, the whole idea of sum is different. In the case of ints, we are generating a conventional sum, the result of adding two numeric values. In the case of sales item, we use two conceptually new names, the result of adding the components of two sales object items. It can be tedious to repeatedly type these transactions as input to the program. You are testing. Most operating systems support file redirection, which lets us associate a named file with the standard input and standard output. Assuming dollar is a system prompt and our addition program has been compiled into executable name. This command will read transactions from a file named infile and write its output. Infile. Named file. Let us associate standard output. Okay, so if I go up, this is called file redirection. File redirection.cpp. Since it can be I didn't know that. That's nice. Please to manually type in input data king and king most was from file redirection to the compiled executable file. .exe input file input.txt output.txt. They can be used definition symbols replace the standard input and output strings in the program. So let's and so, okay, CL. Right. CL. Then 0. And I go plus 1. Okay. A. I want to take input dot txt to output dot txt. I would need to feel I would need to define dot txt. So 45. Okay, it does not work that way. Without for future use. Yes, input dot txt and output dot txt. No. Input.txt output.txt. Yep. This works, but only in command prompt. Already check works, right? Okay. Okay, so okay, first look at number of engines. A program that adds two sales items should check recording, right? Okay, great. Yes. A program that adds two sales items should check whether objects have the same ISBN. Will do so as follows. Okay, include item if ISBN equals to field data must refer to the difference between this program and the previous versions is that if the if that is if the if and its associated else branch. Okay. If the condition succeeds, then we write the same output as before and return 0, indicating success. If the condition fails, we execute the block prints a message and returns an error. What is a member function? The if condition called calls a member function named ICM. A member function is a function that is defined as a part of the class. The member function are sometimes referred to as methods. Yeah. Ordinarily, we call a member function on behalf of an object. For example, the first part, or the left-hand operand of equality expression, item1.icn, we uses the dot operator to say that we want ISBN number of the object. The dot operator applies only to the objects of class type. The left-hand operand must be an object of class type, and its right-hand operand must be a name of the member of that type. The result of the dot operator is the member named by the right-hand operand. The member name. When we use the dot operator to access a member function, we usually do so to call a function. We call a function by using the call operator. The call operator is a pair of parentheses that encloses a possibly empty list of arguments. Something arguments thus calls the ISBN function that is a member of the object named item. This function returns the ISBN stored in the item 1. The right-hand operand of equality operator executes in the same way. It returns the ISBN stored in the item. If the ISBN is the same, the condition is true, otherwise it false. The program again. The bookstore program. We are now ready to solve the original bookstore problem. We need to read a book. We need to read a file of sales transactions and produce a report that shows for each book the total number of copies sold, the total revenue, and the average sales price. We'll assume that all the transactions for the we'll assume that all the transactions for each ISBN are grouped together in the input. Our program will combine the data for each ISBN in a variable named total. We'll use a second variable named trans to hold each transaction we read. If trans and total refer to the same ISBN, we'll update total, otherwise we'll bring total and reset it to the transaction we just read. Okay, it is similar total trans. Yeah. This program is the most complicated thing. We've seen so far, but it uses any facility that we have already seen. As usual, we begin by including the headers we use, iStream, the library, and inside main we define an object named total, which we'll use to sum the data for a given ISBN. We start by reading the first transaction into total and then testing whether the read was successful. If the read fails, then there are no records and we fall through to the outermost else branch, which tells the user that there was no input. Assuming we have successfully read a record, we execute the block following the outermost block. The block starts by defining the object named trans, which will hold our transactions as we read them. The while statement will read all the remaining records. As in an earlier program, the while condition reads a value from the standard variable. In this case, we read a single item object to trans. As long as the read succeeds, we execute the body of the while. The body of the while is a single if statement. The if checks whether the ISBN is equal. If so, we use the compound assignment operator to add trans into total. If the ISBNs are not equal, we print the value stored in total and reset total by assigning it to trans. After executing the if, we return to condition in the while, reading the next transaction, and so on until we run out of records. When the while terminates, total contains the data for the last ISBN in the file. We read the data for the last ISBN last statement, so the block that concludes the most if statement. Okay. So argument, value, positive function assignment obliterates an object's current value and replaces that value in block. Sequence of zero or more. Sequence of zero or more statements enclosed in curly braces. Buffer. A region of storage used to hold data. A region of storage used to hold data. The I/O facilities often stored input or output in a buffer independently from the from actual output. Buffers can be explicitly flushed to force the buffer to be written. By default, reading C in flushes C out. C out is reading C in flushes C out. C out is also flushed when the program runs normally. Built-in types, such a type such as independent output stream object tied to the standard error, which often writes to the same device as the standard output. By default, writes to CR are not buffered, usually used for error messages or other output that is not part of the normal logic of the program. Character string return another term for string input stream object used to read from the standard input class. Facility for defining our own data structures together with associated operations. The class is one of the most fundamental features in C++. Library types such as iStream and OStream classes. Class type defined by class. The name of the class. The name of the type is the class name. Clog. Output stream. Output stream tied to the standard error. By default, writes to clog are buffered. Usually used to report information about program execution to a log file. Comments. Program text that is ignored by the compiler. C++ has two kinds of comments, single line and paired. Single line comments are everything. Condition, an expression that is evaluated as true or false, so value 0 is false, any other value is true. See out stream. Object used to write the standard output, ordinarily used to write the output. Calibration. Data structure, logical representation, and operations from the data. I did compile debug the process of getting a program to execute properly and a file system specific marker that indicates that there is no input in the file. Expression, the smallest unit of computation